Okay, good evening. A little bit smaller group, and I noticed many of the talks that are personal health related, had a bit larger turnout. I think this is as important as anything from my perspective, and Paulo and I were just talking about this. So hopefully a lot of good questions, and I think you're going to find this fascinating. But anyway, Mike Powers, long time here in Fairbanks healthcare circles. Want to remind you that this OLLI program really is the brainchild of Michelle Bartlett, and her connection with the community and the university and the hospital healthcare circles all very tightly tied together. I go back to 67, the flood. William Wood headed up the fundraising drive to build and replace a hospital debt-free. Bill Mendenhall, longtime engineering, was construction committee chair. Mike Kelly, regent, foundation president. Karen Perdue, regent, VP of Health Services, that started the nursing program, restarted the program up here. Of course, now on the board at the hospital. Scott Bell, facilities here and at the hospital. Kari Burrell right here. With Brian Rogers and kind of chief of staff, I guess, and her strategy now at the hospital. But anyway, very, very connected relationship in the community. So I want to point that out. And right through the season, we're wrapping up now, but there are tall timber lectures with distinguished alumni on Mondays, Healthy Living, of course, on Tuesdays, Discover Alaska, focus on local Alaskan issues. On Wednesdays, Music in the Garden. On Thursdays. The Discover Alaska lecture tomorrow night is with Dr. Alyssa Alexander, Tribal Response to the Pandemic. Thursday night, Music in the Garden. 6 p.m., Susan Grace, 7:30, E.T. Barnett String Band, both longtime music groups here in Fairbanks, very active in musical circles. Last night, by the way, Michelle Corner, Dermot Cole, and Dan O'Neill discussing Dan's fifth book on 40-some years of his observations and investigative reporting here, largely in Fairbanks. Fascinating talk, and Michelle cornered them before they left the stage, and they'll do it again next year. But anyway, you'll enjoy it. With that, let me introduce tonight's Healthy Living speaker, Dr. Arghya.
Yep.
Das, assistant professor of computer science at UA, specializes in big data, special hardware and software required to handle immense data sets, specializes in artificial intelligence, recent focus on healthcare, agriculture, and science, founder of the Data Artificial Intelligence Lab at UAF, instrumental in upgrading UAF's high-performing computer resources, multiple awards and grants, very prestigious, National Science Foundation, Department of Energy, NASA, National Institutes of Health, has received the Fellow Award from UAF Center for Innovation, Commercialization, Entrepreneurship. Let me welcome Dr. Das. AI for Healthcare in Alaska, where are we and where are we headed? Could I break in? That's terrible, I wanted to set you up for a little applause, but last chance at a survey, I'll just pass this out. Any notes at all that you have, ideas you have, just jot them down as Dr. Das speaks, and leave them in the back, and we'll make sure we get lined up for next year. So with that, welcome.
Thank you. Hello, testing, working? All right, perfect. All right, good afternoon. So, and although it's sunny, good evening. So, I am Arghya Kusum Das, and everyone calls me Argo. So, with that, let me start my presentation over here. All right. So once again, hello, I am Arghya Kusum Das, and everyone calls me Argo, and I am an assistant professor of computer science at UAF, and so So where is the full screen? All right.
Oh, yeah.
I'll see. Okay, so here is my brief research overview. And so my research actually hovers around data. It starts from distributed cyber infrastructure, which includes supercomputing cluster for AI hardware and all these things, to software, making big, large-scale software for large-scale data analysis, to transfer of big data set over high-performance network in a secure fashion with some technology called blockchain. And also, one thing I'm very much passionate about is the andragogy, the scientific pedagogy for data education. So these are all my research areas, and my research at UAF has been funded so far by multiple different federal agencies, starting from NSF, NASA, Department of Energy, NIH, and so on. And today I am going to present about the AI for healthcare in Alaska. Where are we and where we are heading? So, just to set the mood of today's presentation, just to set the ambience, I just generated this picture. Just to give you the context, we are nowadays in the era where we are actively collaborating with artificial intelligence agent. For example, this particular image I have generated utilizing WhatsApp Meta. It's like a ChatGPT, like a large language model artificial intelligence agent, which is capable of generating images. And then on top of that, I have added all this speech bubble, an ideal example of human AI collaboration for this presentation. Now, in the context of healthcare, the situation is no different. So we are actively collaborating with multiple different types of artificial agents soon. So now we are in the era where AI agents can suggest several medications and several prescriptions for some basic diseases and some basic human health related problems. But the question is, can it be specifically to Alaska's demography or any other specific type of demography? Can it prescribe the medicine which actually works in, let's say, -40 in the absence of zero sunlight? So can it work like that? Can it go to that specific level? Well, maybe yes, maybe not. There are challenges, there are multiple opportunities, and in the next few minutes, I am going to take you to the tour of all those challenges and opportunities, what we have, and I will give you an overall idea. So here is the agenda for today's presentation. First, we will discuss about the current state of artificial intelligence. Then I will discuss about AI for healthcare, some challenges, some opportunities, and then I will discuss some additional challenges and opportunities in Alaska. Then I will discuss some of my data and AI initiatives at UAF and for the call for collaboration. And finally, I will conclude my presentation with a note for collaboration. So, current state of AI. Here in this section, I will give you a brief introduction to the history of artificial intelligence and what is AI. Just to set the environment, just so that you can relate what is going on with the AI across the world. So, let's accept this fact for now that, well, AI is kind of everywhere. So starting from e-commerce to social media to automated vehicle to targeted advertisement, smart IoT, name any field and you will see that there is some applications of AI. There may be some accuracy related issues, there may be some performance related issues, there may be some issues. However, AI is contributing significantly to all these things. Take any of the areas and you will find that AI is contributing significantly. And the same situation is in healthcare also, starting from AI-based healthcare wearables to personalized medicine to clinical connections and chat. Name one field and you will see that AI have started contributing significantly. Maybe at the nascent phase, but it is growing at a very, very, very fast pace, and it will impact the life significantly in the near future. So here is a brief introduction to the history of AI. Now, AI research is not very new. It's the research, the inspiration for creating artificial intelligence has stemmed way back in the decades of 1940s and 50s. And it is for this presentation, I must say that, well, it is intelligence. So, of course, the major inspiration came from the healthcare scientist how to create the intelligence. So, in 1943, neurophysiologist Warren McCullough and a mathematician Walter Pitts basically started modeling the human brain. So, an ideal collaboration of a healthcare scientist and a mathematician or computational scientist to make artificial intelligence reality. So at that point of time, several good innovation happened, and then there were some challenges, there were some issues, the research actually went down, the community lost the focus. Then again, with the advent of internet in the decade of 80s, 90s, when internet was started booming, AI research again got a surge basically. So why? Because everyone started relying on internet, everyone was putting their data, there was a focus on digitization of data. So as more data was being collected, or as more data was digitizing, digital data was appearing in the place, AI research again got surge. However, the major problem was at that time the algorithms that those AI models used, those were very slow, and the computation power was extremely limited. For example, my first computer when I got in my undergraduate days, it has 64 megabytes of RAM. And I'm pretty sure many of you have experienced even smaller RAM than that, right? So, because of those limitations, the thing that happened, the AI model could not analyze much data. And not much data, I mean less amount of data means less knowledge. So there was a limitation in extracting the knowledge. Not only that, and that's why it could not find much real world application in the industry. However, in 21st century, two different things happened which started the AI boom, which explored the main potential of artificial intelligence. What are the two major inventions was? New algorithms came into market, like deep learning. Probably you have heard this terminology. These are some of the buzzwords. But not only deep learning, but there are several algorithms. Overall, the algorithmic efficiency has been improved a lot. On the other hand, in the hardware market, graphics processor unit, it's a special type of hardware which basically is used for video gaming, for high performance, good performance for movie watching and something. Those hardware started making several good progress. I mean, their speed has been revolutionary increased. Speed has increased a lot. Because of this duo effect, the software efficiency and hardware efficiency, now it is possible to analyze large amount of data so that the AI model could find some real world applications. And that's when the AI boom started, and all the major companies starting from Google, OpenAI, Tesla, Apple, Amazon, whatever company you could think of, they started adopting AI for their real world use cases. And the healthcare care companies were no difference. So that's when everything started. So what is AI? All right, so I'm just doing some preamble so that you can connect what is happening. So any idea what is AI? So AI basically means finding patterns in a data. So, so there is some input X, there is some output Y, 10, 13, 15, 18, 34, 37. Can anyone tell me, can you find any pattern in this data? Add 3, exactly. So, yes. So, this is the pattern in the data. So, now you found, so what is the pattern? It's basically a mathematical equation that maps x with y. So, that's basically pattern finding. You found the pattern because the data set is easy. Now, can you find the pattern in here? Anyone? Anyone in the weather who has some interest in weather and all these things? Okay, we are living in Alaska, so it's related to temperature. It's basically x is Fahrenheit and y is the Celsius. So this is the pattern in the data set. All right, so now see, even with this simple one input and one output, we are confused and we could not find the pattern inside the data, right? So what if, when the data set has like 100 or 1,000 different inputs and there are millions of records here. Can we find the data, a pattern in the data? Of course not. And here comes the AI and artificial intelligence. All right. So basically, artificial intelligence is finding the pattern, and this pattern can take any type of shape. It can start from a regular simple straight line to some sort of curvature line to some sort of two-dimensional surface of any form, or it can be 3D, or if you are interested in mathematics, it can go to any type of dimension you can think of, 6D, 7D, 20D, whatever you can think of. So that's artificial intelligence. Basically what AI does, to be a little bit formal definition, it takes the training data set like those x and y, and then it analyzes that data set with some kind of algorithm to figure out the equation, which we call model also. Equation, model, hypothesis or something. So they all have the similar kind of meaning, at least at the overview level. So what they basically does is, they basically learn the equation, which they start from the random guessing of the equation, what it is, and then it basically, after getting the equation or in here, it compares, it gets the output, predict the output, and then it compares the predicted output with the training data sets y, the x and y which already has there, which was already existing. Now, if the predicted data matched with the actual data set, actual output, then we say that the model has learned, the AI model is successful, and you get the AI model output. However, if it does not match, then it basically starts guessing once again. So this is in a nutshell overall what Y does. It starts from a random place and then it feeds the data again and again and again. It starts guessing the equation until it gets the correct equation. So that's basically in a nutshell AI does. Now it's a very simplistic definition. Now AI model, when it comes to the computational efficiency and all these things, it becomes a little harder. Now as I have told, these equations can take any type of forms like a single straight line to something like this S-shaped curve and all these things. I am not going to these terminologies to keep it at an overview level. What does this mean? But they are all different types of models. And these are all like predicting models. So, but one thing I should say that sometimes these real world systems are not as simple so that it can be modeled with one single equation or one single straight line or one single surface or one single 3D model or something like that. One equation is not enough. At that time, what we need to do is we need to create a system of equations, a series of lots of equations that are working together to make that thing working. Yes?
Is it possible to get rid of this black tab? I can't see the top of your slides.
Yeah, I mean, let's see.
Oh, nice, thank you.
Okay. So yeah, so here, sometimes it is possible that, to represent a real world system, we need a series of equations. Lots of equations should work together. Now in this image, each of these small circle is basically representing one mathematical equation, and they are all working together to predict the output, to find the pattern in the data. Not only one equation, but multiple equations. Now, this type of model basically resembles with our brain structure. How? For example, let's say, so just compare these things as one single neurons in our brain. So let's assume that now you are watching this slide, you are watching some sort of image in this slide, something is written in the board, and then you are basically gathering some information over here in the first layer of your brain, first layer of your organ, which is the eye. And after that, your eye processed some information, send it to the brain, the second layer. Then your brain layer process something and make some information, make some wild guess, make some guess that, okay, what is it, what it can be. And after that, it send it to the next layer to figure out like what is happening, what is the meaning outside it. So in each layer by layer, it is delving deeper into what you are watching and and it is trying to make more sense of data. And finally, once the sense is made, then it sends all the action thingy to all your hands and legs, and you react to that. Like, okay, you are understanding all these things or not understanding, or you are asking question or something like that. So that's basically, and because they are similar to our brain, it is called neural network, and each of these things basically depicts a neuron in the system. Now, whenever there are lot of different layers in here, lots of equations, then we call them deep neural network. If there is only one neuron or one single network, we call it shallow neural network. Otherwise, this is deep neural network. So that's the basic beginner's introduction to AI. Any questions so far? Do you all understand? What is it?
It's over our heads.
Oh, it's okay.
How does it determine when to do back propagation? How does it know that it's not had a correct prediction?
So, for that you need to see this picture. So if it does not match the actual values of y, it will do the prediction, make the guesswork again and again and again. So there is some difference calculation mechanism, and if they matches the actual output, then they output, otherwise it will go again for the next guess.
So I have a question. So when it's going through, it doesn't automatically check the y value while it's processing. It waits till all the equations are done and then checks?
In the last step, they
So
checks,
last
and
step,
in the last output layer, they checks.
That's when it checks.
There are some models that can check the output before also, but those are a little bit more complicated. This is just the overview, just to keep it simple. Yes?
It starts out with training data though, right?
Yes.
That's how it's getting to the answer, because you're training it with something that's already,
Okay.
right?
Yep,
I mean, I'm just-
yep, exactly. So you are basically training with the data and trying to match. It's basically the hit and trial method. You are guessing the equation, it is giving the correct output, all right, it's good. Otherwise, do the guess once again. It matches, it gives the correct output, do the matching, and give the output, otherwise do the matching once again. So round and round and round of hit and trial. So basically AI uses the complex logic to predict. Better you can explain a system logically or mathematically, better will be your AI model. Like if it is a physical system or some machine that works with the electrical pulse and all these things, they can be nicely represented with mathematical equations, and for those type of data analysis, AI can give you very good result. However, when it comes to AI for healthcare, there are several challenges. Human health is not just a logic, right? Our health is not just logic or not just a set of equations or something. Like we cannot explain our health only with the mathematical equations. So how can AI help? Now, well, although it is not possible, but all the world leaders, all the community leaders or the company or the AI leaders, everyone saying that, well, healthcare is perhaps AI's most pressing challenges. From Microsoft to Apple to Google, everyone has the similar saying that, well, AI has some potential in healthcare. So what is there? So before going there, how AI can help in healthcare, let's start with a poll. So let's do this. Let's see what is the perspective of AI in this small room, all right, among the participants. So just fill in the blanks. I will fill dash if my healthcare provider relies on AI for their medical care. Comfortable, uncomfortable, or no comfortable? How many of you are comfortable? Okay, only 2. Not comfortable. All right, I am also there. All right, next. Okay, so most of you are not comfortable. Now, the second question, AI would lead to dash health outcomes for the patient. Is it better, worse, or what do you think? Better. Okay, worse. All right. Okay, so there are several like this, no comments or something. All right, now the third question. Are you concerned about healthcare providers are adopting AI very fast? Does it concern you? Yes or no? Yes. Yes, it's a concern. All right. And anyone in this room who thinks that, well, is concerned about healthcare providers are adopting AI very slowly? Okay, too slow. All right. So, okay, yeah. So there are several things. So here, what I can see in the first question, there is a big skepticism among everyone, right? Like, well, whether AI is good or bad. And this is not only in this room. It is not limited to this room. Pew Research has done a big survey across the nation which exactly reflected the way you voted, you polled for. So for example, like fewer than half in the US expect that artificial intelligence in health and medicine to improve patient outcomes, and many of them are not comfortable. Many of them are uncomfortable rather than comfortable with AI reliance of the medical providers. So there is the sentiment is against AI at this point. That's the fact. All right. So, and not only that, even the inventor of ChatGPT, he told that maybe I'm a dinosaur here, but I really do not want to like entrust my medical fate to ChatGPT with no human doctor in the loop. So it's not only us, it's not only the common people, but also the inventors of the AI models, they also have some skepticism in them that how AI can be deployed in the medical system. So in the next few slides, I will discuss that. So one thing we should understand clearly, when we are talking about AI in healthcare, are we designing AI to replace the doctors? The shortest answer, no, we are not. That's not what we really want to do. Doctors and clinicians, they really ask for explainable, trustworthy, and cooperative AI for human-AI collaboration. That's our goal. Now, so once again, the question, how can AI help? There is skepticism. We don't want to replace doctor. But so then how can we utilize AI? Of course, this has some potential. Otherwise, why everyone saying that it is the biggest market, why it is a buzzword? Probably the direction is kind of divide and conquer. Divide and conquer the entire sector. The first division is, of course, there is health and there is care service. So that's the first division. Next, divide the health into multiple other granular pieces. Maybe divide it demography-wise, then divide it organ-wise, then divide it disease-wise, and then apply artificial intelligence. The same thing for the care service also. First, understand your care model in the state or in the organization or anywhere, okay? And after that, break down it hierarchically and then apply AI. Now, I would like to tell you that when possible, there is an emphasis because AI is not a panacea for everything. So we need to be very careful about when we are utilizing AI and where we are not. But anyway, once the AI microservices, after this dividing and all these things, once the microservices have been developed utilizing AI, then it's probably the time for conquering multiple different microservices together, which is totally controlled by human agent to make a human AI collaborative pipeline. So that's becoming our goal in the next decades or somewhere for the healthcare practitioners. So given that we follow that sort of model, of course there are some pros and cons. So the pros are, of course, improved diagnostics and accuracy. You all told that, okay, patient outcomes can be better. So of course there are some pros. There can be improved personalized patient care. Of course, if you can divide the patient, divide the health into demography, divide the health into region-wise, community-wise, of course there will be personalized patient care is possible, which is one of the pros. On the other hand, if you can divide the care model, care service properly, you could get increased operational efficiency. But on the other hand, even after all the deployments is perfect, there are some opportunities, there are some threats also. The major threat is ethical and privacy concerns. AI model needs a lot of data for training. So how to share the data while complying with all the HIPAA and other regulations. So how to share that? High implementation cost. Now I was talking about those GPUs, right, a few minutes back. Those GPUs consume a huge amount of energy. Their cost is also very high. Recently we have set up a supercomputing cluster which costs almost $1 million only for 6 computers. So they are high cost computer for research. So implementation cost is very high. On the other hand, the major problem is risk of over-reliance. We started relying on ChatGPT output, blindly, which we should not do. So these are some of the cons where we should be very much careful about. So when utilizing AI, we need to remember that AI is just another tool. It's like a search engine. Easy to find the answer, but must be reviewed and validated. And this is an added responsibility for the clinicians or the medical practitioners, the doctors, that whether AI is working well or not, validate the model. And always need to remember that AI is not a doctor's replacement, but it is the doctor who need to use the AI responsibly. So for better impact, basically, we need to we need a human-centric AI. In the other sectors where like we are analyzing machine data or sometime like physical data or something like that. Physical means all the nature data or machine data or some other system-related data, industry data or something like that. We call it human in the loop in an AI-based system. That means that AI is in the power of controlling the entire process, and whenever required, intermittently human agents, or the human regular human beings, the laborers, are basically providing the inputs and all these things. But in healthcare, lives are at stake, well-being are at stake. We need to follow a completely different approach, which is AI should be intermittently used and humans should be in control of what AI is doing. And by saying what AI is doing, I am saying that, well, explainable AI, deployment of AI, how AI model is behaving, where it should be deployed, how to deploy, everything I'm covering with that. So AI will be working as a microservice or agentic workflow kind of a way, and humans should control this entire thing. And nowadays, it's the time for working multiple different types of AI agents together. So it's not a dream anymore. So all multiple different AI agents can work together, communicate with human agents also. So those are possible. So these slides, basically, I am not going too much detail of that. This is a technical work breakdown of the previous slide that I have just discussed. So there are 4 main pillars, like striving for human and ethical utilization of healthcare, then standardizing data, develop regulations, and support clinicians training, which are like challenging for developing this sort of human-centered AI applications in the real world, to deploy real-world application in some hospital or in some places. So this is basically the technical breakdown of the similar thing that I have discussed earlier, and mostly targeted for the clinical entrepreneur who are really trying to design some sort of services and so. So, and not only that, the opportunities are lying in the ancillary sectors also. For example, whenever we are talking about healthcare, according to Bureau of Healthcare, it's in the USA, physicians are only 3% of the entire healthcare workforce. There are a lot of different types of service directly or indirectly related to healthcare, which includes hospital management, insurance plan, lifestyle management, law enforcement, training, and a lot of different things. So all those things can be directly improved by utilizing artificial intelligence. What insurance plan is better? By checking your some of your health statistics and something like that. How to do patient management. Let's say I get 200 patients, but I have like, let's say 10 hospital beds. How to manage them properly. Managing manually or managing with a deterministic system or something, it's very, very, very hard with regular mathematics, because and when it is complicated with which diseases are contagious, who should be kept separately from others. So all those things, when played together, all these things are challenging, and there comes the opportunity for AI in these ancillary sectors. So basically these challenges are, no matter whatever be the applications for artificial intelligence, it may be directly related to the health, or it may be some ancillary service related to the healthcare. These are some of the real challenges that the next generation AI folks or the healthcare practitioners need to address, and need to address as soon as possible. These related to like addressing the bias and fairness, which demography you are targeting. Are they represented well in the system? What are the complexity in design and implementation? What about the data privacy and all the consent? How are you training the AI model? Are you getting the data complying to all the different types of regulations and everything? Then lack of variety in the representation of the data, skepticism among everyone, then regulatory and ethical ambiguities. All these things basically pose challenges, and these are we as a healthcare professional and the AI scientist has these challenges to solve next in the few years. So basically all these challenges, when sum up to one single word, it's basically build the trust. So when we are talking about the trust, it says like specify the target population, clearly mention if you are developing an AI model, which population you are targeting. It is impossible to make a single AI model that will work for all the different types of population or all the different types of disease or all the different types of organization. So you need to be very specific about the target population and validating the model. This is very important. There are lots of papers nowadays are coming superfluously, like, okay, we are getting 90% accuracy, 99% accuracy, even 100% accuracy sometime, but is your data validated? If it is 100% accurate, what are the population on top of which did you validate the data? Those are the important questions that everyone needs to ask. And so those are the real challenges. Now let's talk a little bit about some additional challenges and opportunities in Alaska. So when it comes to Alaska and when it comes to healthcare, there are multiple different challenges. So challenges are lying because of the geography, because Alaska has this polar and circumpolar weather. We get lots of different types of unique diseases in here. The remoteness, over 80% of Alaska is not connected by a road. So how to deliver healthcare in those places? Then there are workforce shortages, infrastructure issues, natural hazards like wildfire and harmful algal bloom that started recently, and that, I mean, I should not say started recently, but they started in a more increasing amount recently. And then there are lots of demographic variety across Alaska. So these are some of the additional challenges that the healthcare provider or AI-based healthcare provider should remember when developing their AI-based services. So can AI address these challenges? Well, I should say AI is not a panacea for everything, but it can address the challenges a little bit. For example, geography. You need to design a separate model with the Alaska resident to make it working here. You cannot say like, well, the model that is working in India, in my home country, that will work in Alaska. So these are not possible. So we need to develop a different type of model in here. Then remoteness. We need to develop smart telemedicine platform. There are technologies available, microservices available. We need to build the pipeline. We need to develop the AI-based pipeline to mitigate some of these issues. Workforce shortages. AI can help healthcare providers to manage their workload more efficiently so that more mundane jobs can be done by artificial intelligence and more health-related like analytic jobs should be done by human or something. I mean, more health-related issues, more critical issues. Infrastructure issues, natural hazards. With the advent of drone, autonomous systems and everything, you can, AI has significant amount of potential to deliver services, to deliver drugs, to deliver multiple different things to multiple different remote areas. So when it comes to Alaska, one of the major challenges that AI needs to address is availability. Can we utilize artificial intelligence to make the medical service available and accessible to multiple different places? For example, according to Health Resource and Service Administration, HRSA, about 75% of communities, including Juneau, lack road connection. Reaching care often requires travel by plane, ferry, ATV, boat or snow machine. What happens if it is too cold and if nothing is working? Can AI help in those situations? Well, there are partial solutions utilizing drone, but it is yet to develop. So those are the challenges, and of course, whenever there is the challenges, those are the future opportunities in healthcare delivery service in Alaska. And not only that, we need to prioritize the diseases that are unique in Alaska and that does not get much attention in the traditional healthcare research, because Alaska is sparsely populated, and when you will granularize into multiple different communities, you will see that every community has very less population. So it happens, it's not very uncommon that the disease, based on the overall population, it is impacting very small number of people, but when it comes to the community, the entire community is on the verge of extinction. So these type of things can happen. So this is another thing like which we need to prioritize utilizing AI. And because there is not much health attention for the traditional healthcare research, probably they are the best candidate for AI-based healthcare research, because the medicine has not been developed yet very nicely. So can AI help in there? So these are some of the challenges. So here are some promising use cases. I just researched over internet, and I found that, well, in Alaska there are lots of use cases across the state which is utilizing AI for multiple different types of healthcare services. For example, Alaska Neighborhood Healthcare utilizes AI-powered tool to transcribe and format clinical notes. Stroke Coalition is utilizing AI for strokes and strokes-related services. Unidoc Health is addressing some fundamental challenges of regarding like related to EHR and other documentation, which I believe has potential to serve like multiple other services on top of it. It can facilitate multiple other things. And finally, Stryker Mako robotic arm is in Fairbanks. So they can use like robotic arm to provide hip, knee, ankle, shoulder joint service, which is also another use case for artificial intelligence. So, so we are almost at the end of our presentation. So those are not only the, so those are the example what is happening across Alaska and all these things. So, and since this is the last presentation of this lecture series, I just took some time to retrospecting to the prior topics in this lecture series. And what I found, and then did some research with what are some of the AI applications in these topic areas. And well, not very surprisingly, but well, I have found that well, AI is making promising advances in all the areas that have been covered so far in this lecture series, Healthy Living lecture series. And two of the things, modern approaches to chronic pain and how to starve cancer, they are probably one of the most focused area when it comes to AI for healthcare. So I have found multiple different papers which are working in this domain. Some of them are well advanced in terms of AI, some of them are not so well advanced, but AI started making some progress, and hopefully in near future we will see some more good use case for AI in healthcare for everything. But to make those a reality, for more impact, for better future Alaska, we need more collaboration between the scientists and the healthcare professionals. We need more AI literacy. The clinicians and the patients, everyone should know more about AI, and they should know like what AI can do, and more importantly what AI cannot do. What are the challenges they need to address? Everyone needs to have that literacy. Also, we need to focus on more data sharing while complying to adherence. AI cannot work without much data. So sharing the data with all the regulations, complying to all the regulations, we need to address that. And finally, of course, we need more investment to do multiple different types of pilots in Alaska to explore the full potential of AI in healthcare. So here are some of my initiatives. For example, we have set up the world-class supercomputing cluster in the Butrovich building of the university in the data center, which has the latest graphic processing unit, GPUs, to train multiple different types of healthcare AI model. We have a lot of storage, we have a lot of memory per node. The 6 nodes are $1 million, so it is a significant enhancement from NSF. So it can address multiple different data related challenges if anyone is interested to apply it on healthcare. So it is possible. And also we have data and AI lab. We focus on archiving, analyzing and disseminating data with education and research focus on multiple different sectors. And this lab is mainly funded by NIH. So of course we have some focus on the healthcare data also. So here are some example of health initiative in our lab. We are doing a pilot study for algal blooms impact on paralytic shellfish poisoning, which is not unique, but Alaska is suffering the most from this disease and in the coastal community. So, and why this type of disease are important, as I have told, like sometimes the prevention is the only option. There is no antidote available. Now, in remote Alaska does not have any good healthcare infrastructure. When it combined with the poor travel infrastructure, poor transport, and all these things, it becomes life-threatening. And whenever it becomes life-threatening, whenever it comes to the population, to the community with a less number of population, that we are in the verge of, we are in the verge of extinction of those type of communities. So these outbreaks, although total number wise may not affect many people, but when it comes to the small community, they are pretty serious, and we need to address those things. And another example health initiative, it is still in the feasibility analysis phase. It is basically a smart telemedicine platform. We are trying to connect with some vendors who develop portable health equipments. Then we will store it in the cloud storage, then generate some AI model to detect personal health anomaly and something like that. So hopefully in the near future, if everything is good, we can develop some good telemedicine platform. And for everything, I'm looking for collaboration over here. So in conclusion, it's basically AI is everywhere. Healthcare is one of its pressing applications. AI is not to replace the doctor, this one is the bottom line, but to assist in their decision making. There are multiple areas of healthcare, including care delivery, insurance, hospital management, where AI can be readily utilized, not only just health prediction or something, disease recovery or something like that. And Alaska, with its unique location, poses several other challenges. Some initiatives are already underway. We just discussed that. And for better future, we need more collaboration, more awareness, and more funding, more investment. So with that, I would like to conclude. And any question?
Could I do this? Could I ask, I know there will be questions, could I make sure you speak into the mic, or Dr. Das, if you repeat the question, because it won't be picked up. But let me just kick it off with a question.
Sure.
So, thinking of Fairbanks, Alaska, and I appreciated your retrospective perspective. Great.
Sure,
how was this applied to previous lectures? And I also appreciate the skepticism and trust comment that has got to be built before you use it for any big question. My question is about planning, not an individual procedure, but just planning big services. If I think about the history of Fairbanks, when Dr. Carroll pushed the cancer center, because of the trust in Dr. Carroll, it really was not controversial at all. It went through, and it was fairly special for a small insular community like this. When the cardiology program came along, there was great skepticism, primarily out of Anchorage. Certainly some issues here within Fairbanks. It kind of divided the medical community for a bit. Ultimately went through it, one of the better decisions I think that was made. Question, you've got a multi-million-dollar investment on some of the latest technology. At what point is it appropriate for a community this size, just like cardiology and just like radiation therapy? How could AI, and what are some of the variables, and Kari may have some thoughts on this as a strategist, what are the variables that need to get into that question in understanding the bang for the buck? When does it make sense to add some whiz-bang new technology, as opposed to using that money for primary care, better health, long-term care, more needed services?
Sure. So if I understood the question properly, you are asking me about you decided some area and then you would like to spend the fund, or you are trying to decide which area it should be used, which healthcare area it should be used.
In this case, I'm talking about one particular issue. What if we had to put another cardiac cath lab in? How could we deploy AI in order to really build trust and confidence? Because there was great skepticism. What are those variables? How would you build it in? What would you use? What technologies in AI, et cetera?
Yep. So that's a very good question, actually. So, and well, I mean, we are already working in this domain basically, and we have a paper which is not published yet, which exactly to answer this question, what you would like to do, I mean, for the planning phase to answer all this trust and this ethics related question. Well, I am a computer science professional, a software developer, or you can call me a product developer. And this trust, when it comes to AI-based healthcare product, it should start building from the day one when we start building that product. So there are multiple different stage for software development. It starts from feasibility analysis, given that we have that. Then it basically has this data collection and all these things. What data you will collect. From that point, you need to start considering these issues, like what demography you would like to target, what data you would like to collect. Then once you have designed that, then probably it's the time to design, like, so when it comes to data, it may be, you may need to address the problems like data bias. So I'm not trying to be more technical, but well, there is something called data bias. Let's say you want to target the entire Alaskan population, but you just collected the data only from the coastal side of Alaska and not from the interior Alaska. Will the AI model work? Maybe not. So that's called data bias. So that's probably the first thing that you need to think about for planning. What community to target, how to collect the data. Next comes the design phase. Now, whenever it comes to design phase, AI is basically a software or hardware. Whenever it comes to design phase, there is something called algorithmic bias. Now, algorithmic bias is a totally technology thingy, so I'm not going to too much detail of that, but it's basically like how you will design your rule system. Let's say if the data is from this part, the AI model should behave like this. If the data is from that part of Alaska, AI model should behave in this way. If some part is missing in your algorithm, in your software, then that can cause problem. So first data collection, then design. After that, the implementation phase. That's the most important part. But and with the advent of this LLM, folks are relying on coding, just utilizing this ChatGPT and all these things. So they need to validate their codes and everything very nicely to make to say it like, okay, it is a foolproof or it's a good code. So there we need to do some sort of planning. And finally, the deployment phase. How to deploy it so that everyone can access it. Everyone means the community that you are targeting, how they can access your software. Are you deploying it in places which is readily available in Fairbanks, or you are deploying it in Anchorage so that I need to travel 2 hours of, 6 hours of driving and then need to access it. So those things should be considered in the planning phase.
Could you use AI against itself to identify potential biases and build against it?
Well, this is a very good question, and I should not say that I have a definitive answer in that domain. So AI to analyze AI biases and so on. So for that probably, so you have some answer. Oh, okay. So yeah. So here basically, I personally am not a big fan of utilizing AI for finding loophole in AI. However, with this advancement of LLM and context-based learning, it can be addressed in near future, because with this deep learning and all these things, we are just relying on the data. whatever data we have, we are just relying on the numbers. However, whenever it comes to large language model or ChatGPT, their entire search space is the entire internet. So that helps them build the context first before saying something, before giving some sort of output. So those type of technologies in near future can be utilized for finding ethical violations and all these things based on the context. So yeah.
You just repeat the question, please, when it comes to.
Yeah, sure.
Okay, so, and I'm not sure this might not be in your wheelhouse, but you might know, where people have talked about it. Right, there's limited funding, right? We know there's limited funding for whatever we're doing for healthcare. And you have to make a choice. How do you know if the return on investment is going to be better for putting your money into an AI model and utilizing AI, or putting your money into, a new particular type of care, right? Mm-hmm. When do we have models that will show us when your money is better spent on AI versus when your money is better spent on a new little clinic or a new nurse or whatever?
Right. So that's a great question. So just to repeat the question, I mean, let's say you have a small amount of funding. I'm just trying to summarize the question. So you have a very small amount of funding and you have two different options. Like either you go through the AI path to address some of the disease, or you should open a definitive path like opening a clinic or some traditional services or something like that. How to choose them? So that's a very good question, and I can address it partially. I should not say, because that needs a lot of feasibility analysis, and we call them requirement engineering in software engineering concepts, so I'm not going to that much detail. But well, the first thing that we need to say before designing AI and all, is data available to build my AI model? Do I have enough data to build an AI model? Whatever service you are talking about in the context of that service. If not, then don't use AI. That's the straightaway answer. If you do not have data, there is no question of AI. And now, then let's say you have data. Then the next question comes is the workforce. Do you have talented workforce to develop the AI model properly? To deployment? And when I am talking about developing the AI model, I am not just talking about writing a TensorFlow code to give some good output. I am talking about the entire software development pipeline. Do you have that workforce with you to develop that? Now, that's the second stage of feasibility analysis, basically. I mean, if you need to hire a lot of folks and need to spend a lot of money, you are already out of budget. So probably that's not the way out. The other one is good. Now here basically, so one of the thing is like when you are talking about, so these two are probably the major factors: the data and the workforce, talented workforce that you have, that you need for that. The number 3 is basically what you need to do. This AI field is changing very rapidly. So everyone needs to be very much, that should be a dynamic team, honestly. That is also in a way workforce related thing. However, they need to be susceptible to change. They need to accept the change. For example, very recently, AI was not standardized at all. Very recently, in 2024, November 2024, there is something called Model Context Protocol, which is the first ever attempt from 1940s until now, which is the first ever attempt to standardize AI agents and all these things. So everyone who is working in the team, they need to be aware of these type of technologies and need to evolve the system in that way, need to make it a robust system. So these are some of the deciding factors when doing this AI model. Basically what you need to remember, AI model has need a significant amount of investment in the beginning to save some operational cost in the future. So that way you should start doing the analysis, how and where, and you should make the spreadsheet and that way. So these are some of the answers. Yes?
So, just so I can basically understand, first of all, thank you for the presentation, it's really been fantastic. I've learned a lot.
Thanks.
But this shows how much I've learned. So what I understand is we all know computer programs, we have apps, we use a computer program at work or something like that, word processing, it's an application, it's a computer program. So what AI is a higher level computer program. That's all we're really talking about, is that correct? Just a higher level computer program. Now, let's say that she's considering developing AI and instead of having a clinic. Well, is there some consulting firms now that exist that she goes and contacts in Silicon Valley or in Fairbanks or in Anchorage, where you go talk to a consultant and say, hey, this is what I want to do, I want an AI for this. Are there such companies like that that do that work?
So consulting companies, so I should go back to this slide. Well, there are a lot, but before spending money, make sure that you are investing in the right place, because there are a lot of companies which are coming and promising a lot, but they are not really providing the service. So make sure you are investing on a trusted service from someone. So now to give some example of companies, here you can see like this Unidoc Health. This is one of the AI company that provides consultancy service for multiple different clinics. Then there is Rapid AI, somewhere it should be here. So Rapid AI is another company who gives multiple different types of AI related service. Then there is a company called Analytic, which gives consultancy services for AI, and they have their products for that. There is another company called Sera. So they give some kind of consultancy service for general purpose physicians. So now and then there is like Gene Bioinformatics, which basically specializes on their consultancy on precision oncology. So the way to approach this problem, yes, there are consultancy, there are reliable, there are unreliable consultancy, and not only that, there are some consultancies which are specialized in some particular type of disease and some particular type of services, healthcare services. So you need to figure out that before going to some consultant. But yes, there are several consultancies out there. Yes?
So your talk has been very good, and I agree, I've certainly learned some things. But it also brings to mind several concerns. One of them is, as you mentioned, training personnel. So there are some medical programs, educational programs, who maybe the soon-to-be doc only gets a semester of pharmacological training because they're not a pharmacist. They're going to rely on that person when they are out in the hospital or the clinic or whatever to rely on them. But they have so little background in it that they may not be able to understand. So when you look at having to have, and you had all those different providers having to have some understanding of AI and using AI, and it wasn't going to just be your docs, and it wasn't just going to be your human resources, and it wasn't, everybody needs a piece of that. And so how many more months or years of training needs to go into each one of those career paths? How much more training needs to be done by your healthcare facility to keep people up as these things change? I mean, there are some, not the cost of the part of the things that you're doing in the data stream and stuff, but actually the using it then when you get out, someplace. And one of the other concerns that I have, that healthy skepticism or whatever, is it's only been 12 or 14 years since a lot of people have moved to electronic medical records. And we know that there are incorrect data within those medical records. And some of that was because somebody set up a nice little logarithm that says, check this, and it will tell you that you did this part of the thing. But then, to be helpful, they also added on 2 more statements. And so your nurse or your whoever may check that box, and then if you get your medical record and look it over later, you find out that, oh, they talked to you about X, Y, and Z as well. And you know you're not crazy yet, they did not. And so you have incorrect information then, so then it's the garbage in, garbage out thing when you start trying to predict and develop plans for that kind of thing. And in some cases, you can find some real blatant things and go in and say, hey, this is wrong. This actually happened in my life in this year, not the year you have in my record. Can you change it? And either because of policy or inability to work with that program, they cannot, and it doesn't get changed.
Mm-hmm.
And so when you look at trying to conglomerate all that data to use, you've got some data that's not really very good. And another thing, I guess, is 30 years ago, or maybe more, we used to, as we started using more technologies in hospitals and nursing homes and all those places, we used to say things like, if you're going high tech, you need to also find some ways to go high touch, because that's part of what healthcare delivery is, that we're working with humans, we're not working with a machine, those kinds of things. And I'm not sure how these kinds of systems fit with that, or even if that's a concern they talk about nowadays. But, so those are all just, I don't expect you to have answers, it's just, oh, there's so much.
Sure. Yeah. No. That's a wonderful comment, actually. And well, I mean, I really do not have answer to all of these. But what I understood from what you have told, like 2 or 3 different questions. Correct me if I am wrong. Number 1, how to conglomerate all these sectors together, because this is huge. How long it will take for trainings and all these things. That was probably your first question, right? So we are in computer science, so we always rely on the concept of abstraction. So abstraction means, well, I am a software engineer. I don't have much idea about how the hardware for Apple iPhone works at all. So we need to we need to take probably a bottom-up approach for the training. So which are the most fundamental thing that you would like to train your workers or your workforce? That is probably the first problem that you would like to address when it comes to training. Once you get the workforce there, once you can put trust on that team, on top of that team, you need to develop the next layer of your service. That, all right, I mean, this thing is done, so probably the next phase of training should address this much. So it is impossible that every healthcare worker will learn every aspect of AI in every aspect of healthcare. It is not possible. It is to the clinical entrepreneur who will layerize the services one on top of another. And if we can do that properly, then that will be the best deployment. I mean, I should not say best is a very strong term. That should be the most feasible, probably, one of the better solution for AI deployment and AI training, development and all these things. Maybe, well, the AI health worker, they don't need any knowledge about how the AI model works. Maybe they just need to say, like, well, how to validate the AI model properly. On which data set, on which community data set they need to learn. So validation should be one part of training. Development should be another fundamental part of training. You put trust on development, then you put trust on the validation sector or something like that. So layer by layer you can target, because otherwise, including a lot of permutation, everyone will be totally lost. But if you just do a layer by layer approach, that's a much deterministic approach, and you can see the end where you can start your organization. So that's probably the answer to your first question. Next, so how to organize the training. The second thing that you have asked, like, well, at some point, like how all these AI things and everything will work together. I mean, so when there is a bigger technology, and how you can you use something like when there is a big technology, then high tech and high touch or something?
High tech, high touch, that's just because we're working with humans, and so as we introduce more machines and more things done by machines and all that kind of thing, the patient can become more isolated.
Right.
You know,
Yep.
somebody may say, well, I went to see my doctor, but
Yes.
he didn't even touch me, and he didn't look up from his tech, you know?
Yes.
Those kind of
Sure. And also you told about the error in the data, right? And so error handling will be there. It's not about only AI. It will be there whenever you are developing anything in the digital market. It can be a digital device. They are prone to instrumental error. It can be a software. There can be multiple different types of errors. And when it comes to the healthcare and AI, there could be the data error. Now, to handle those errors, there are several techniques, fortunately. I should not say they are like 100% proven technique, but well, with 90%, 95%, 99% accuracy, they work. For example, like one simple example could be like eliminating the outlier. Like, let's say you are analyzing a patient, one particular patient's data from the patient's birth or something, and suddenly you saw that, well, in all the documents he checked yes or something like that, and suddenly there is a no for the same record. Probably that's an anomaly. So you need to utilize some sort of algorithmic thing to make it error. It's kind of error proof or more concrete for better result. So you need to build the systems like that way, because errors are norm. It's not just happen. It happens all the time. So it needs to be fault tolerant. So that should be the behavior of the system. And well, for the last part, like this, because we are discussing with the human and all these things, well, we are talking about human AI collaboration. I am not really sure like how to better answer this question, but well, the future will say. We are moving forward to that direction.
Out
Yes.
of respect for time, maybe last question?
Okay, I just got my yearly physical, so it's called, and it was a 20-minute conversation with an assistant, would have been 10 minutes with a doctor, that's all insurance allows, and a blood test. And really I didn't find out that much. What I'm more interested in the high touch. Your CV is intimidating, granted, but I wish you had an agent that would address personally the people in this room. What I want is GPT-5, I want access to DeepMind, something. I want it to walk me to the question, these are the symptoms, what about this? These are the symptoms, what about this? Granted, AI is not perfect. Never met a doctor who was. Met some good doctors, met some bad ones. AI is, that was your slide up there was 1922, what people thought about AI. People are years behind. It's exponentially ahead of what people think it is. Okay, but it gets some wrong answers. But in the villages or whatever, I want a breath analyzer. I want to put a drop of blood every morning, and I want it to not tell me if I got too much sugar. I want to know what's in that drop of blood, and I want it to compare it to my genome, epigenetics.
Mm-hmm.
I want AI to explain to me what no doctor through insurance has the time to explain to me. I got a great doctor. I get to visit him every couple of years for 10 minutes. But AI can actually, when I went to Costco recently, the gal didn't have a mask on. I said, you had a mask on last week. She said, oh, I had COVID last week. This is the gal checking you at the door. So I go back to the Costco to see if they got any kits for COVID, and they didn't. They don't sell them anymore. And yet, in the downtown post office in September, I caught COVID from a MAGA who just got out of bed with COVID, went to the downtown post office. You know, I want access to medicine, which I don't have now. This theory is important. What can you, how can I have, give me a URL for DeepMind that will tell me, do this, try this, go see this doctor.
Awesome. That's a big question. That's I do not want to make a lot of promise in that, but there is a company called K Health. K Health, I believe. K, letter K hyphen health. Yep. So they basically does this type of things. They have, I'm not sure whether I wrote it in here.
Which
So
thing
let me
specifically?
Let me see. Yeah, this clinical connections and chat. So they are utilizing these chat agents for, I think, connecting it with genomics data and everything. It's a little more advanced. They don't give that type of service yet, but they just started. They chat with you and exactly like suggest some rudimentary things that you can do, and then if you need, they will connect you directly with the doctor. So they started this service. So is that?
I'll look them up. There's also blood
Yeah.
draws that will test for 50 different types of cancers, most of which that have no test. It costs too much, and for years I've been saying, will the hospital do this every 2 years for people, and will insurance defray the cost? And then I don't have to, they don't have to read my obit. He bravely bullshit.
So yeah, those are some futuristic
So
things.
out of respect for everybody's time, we'll call it. Thank you very much for the great questions. And Dr. Daz, thank you very much for the questions.
Thank you.